Hey guys, so right now we're going to talk about the solid state of matter. So what happens when molecules kind of form solids and the types of solids that they form. So two different categories of solids are crystalline and amorphous. So a crystalline solid, it's a solid in which the atoms, ions, or molecules, so I'll get into different categories for there, but they are atoms, ions, or molecules, they're organized in a very specific and repeating pattern. So arranged in a definite repeating pattern. The other possibility is an amorphous solid, where these atoms, ions, or molecules aren't formed in a repeating pattern. They're just kind of flowing around. It lacks an ordered internal structure, and these atoms are randomly arranged. So as you can see, a crystalline structure has this definite pattern, whereas an amorphous solid is just kind of all over the place. A good example of this is ice. If you freeze water and you do it really slowly, that water will kind of form a definite crystal structure, which is pretty cool. But if you flash freeze it or freeze it too fast, the atoms don't really have time to arrange, and you'll get an amorphous structure. So, solids are also classified in different categories, and they're classified based on the nature of the forces holding them together. So these are four categories that are usually used. There's an ionic solid, metallic solids, covalent network solids, and then molecular solids. So now I'm going to go more in depth in each of these individually. So I will start with ionic solids. So as the name implies, ionic solids are composed of positive and negative ions, so these full anions and cations, and they're held together by those electrostatic interactions between the different ions. So like an ionic bond, these solids are all held together by those ionic bonds. And so these are pretty strong because as you remember, ionic bonds are pretty strong back when we were learning about intermolecular forces. So since they're so strong, they usually have high melting points and they're pretty hard. But what's kind of unique is that although they're hard, they're pretty brittle. And that's because if you crack that structure in any way, it'll kind of disalign those charges, and so it'll shatter. So they're hard but brittle. And then when they're in a solid state, they don't conduct electricity, and that's because those ions are being held pretty securely in place and they can't flow around. But if you take that ionic compound and you melt it or you dissolve it, now those ions are free flowing and they will conduct electricity very, very well. So the next category is a metallic solid. Metallic solid are solids formed by metal atoms, and so they're often described as a uniform distribution of nuclei with like a sea of electrons. So the nuclei are kind of held together, and then the electrons kind of form a sea around them where those electrons are pretty free flowing. And because those electrons are pretty free flowing, they have very high thermal and electrical conductivity because those electrons are able to flow around. They also have good metallic luster and malleability. They're very hard and quite strong. So metallic solids. The third category is a covalent network solids. These are solids that are held together through a network of covalent bonds. So these include crystals of diamond, silicon, and sand. Since they're held together by these covalent bonds, they're relatively very strong, and they're characterized by hardness, strength, and high melting points. So you might know that diamonds are one of the hardest substances, and they are held together by these types of bonds. So lastly, we have molecular solids. So molecular solids are solids of just pure full molecules held together. So a good example is ice. So ice is frozen water. And so when water freezes, those water molecules will kind of form a solid with their coordination. And since they're composed of neutral molecules, the strengths of the attractive forces between the units vary widely. You can have some with very high melting points, some with very low melting points, some that are very strong, some that are very weak. But there's kind of a order to that madness where small symmetrical molecules, so small nonpolar molecules, have very weak attractive forces, so they form solids with very low melting points. So this would be like oxygen. It's usually a gas because it's very small, it's nonpolar. In order to make a solid, you have to bring that temperature way, way, way down. Substances that are large, so large molecules, they have more attractive forces because they're bigger, so there's a greater surface area. So since they have more attractive forces, they have relatively higher melting points. And then lastly, structures with polar molecules, so molecules that have permanent dipoles, they have solids of higher melting points. Okay, so those are the different categories of solid. The last thing I'm going to talk about are crystal defects. So this is usually in crystals, and there are different categories of defects. And so one is a vacancy. This is a defect when a spot within a crystal structure that should have a specific atom is vacant, so nothing's there. Then there's a substitution defect. That's where a specific atom within a crystal structure gets replaced by a different atom. This can be an atom that is smaller, larger, the same size, and then if it's the same size, it won't really distort the crystal structure. If it's smaller or larger, then the crystal structure will be distorted to some degree. But that's a substitution defect. And then lastly, we have this interstitial sites. These are, this is a defect where an extra atom is located in the spaces between the atoms of the structure, and I have this kind of drawn out. So if this is a crystal structure where the gray atoms are what is usually in the structure. Right here is a vacancy where there should be a gray atom, but there's nothing. Right here is a substitution where there's a red atom when there should be a gray. And then here is that example with that extra atom, and it's this little guy located in the space between gray atoms. So that is how you would categorize solids. Hope you guys are staying safe and healthy.